Assalamu alaikum. I am Dr. Monirul Islam, working as an assistant professor in the Department of Mathematics, Aligarh Muslim University, Aligarh. As a part of an assignment of a refresher course, subject refresher course organized by UGC MMTTC, Aligarh Muslim University, I am going to give a talk on solution of algebraic and transcendental equations. The motivation of the talk is in scientific and engineering studies, a frequently occurring problem is to find a root of a solution of the form f of x is equal to 0. If this f of x is quadratic or cubic or biquadratic, then there are algebraic formulas which can be expressed in terms of their coefficient, or we can find the roots easily. For example, if we have a f of x is quadratic, that means f of x is equal to x square plus bx plus c is equal to 0. So we can easily find the roots of this quadratic equation by using the algebraic formula, that is x is equal to minus b plus minus under root b square minus 4ac upon twice a. So this is the formula how to find a quadratic roots of a quadratic equation. Similarly, we can find algebraic formula for cubic or for biquadratic, but problem is occur when we have a f of x is polynomial of higher degree, maybe 1000 degree or 1 crore degree. Then how we will apply this formula, or the f of x involving exponential function or trigonometric function, or f of x does not have exact solution. In all of the above case, the algebraic formulas available in the literature are failed to provide a roots. So in that case, we are going to find the approximate root instead of exact root. So for to find the approximate root, there are so many method involved available in the literature. So here we consider some famous method. Uh, that is bisection method, regular fallacy method, iteration method, and Newton-Raphson method. So these are the method which going to help to find the approximate root, not exact root. So due to the lack of time, because they have given us 5 to 7 minutes, so in this lecture I am going to consider only bisection method. So before I start for bisection method, there is a famous result which is the result. This is the result. That means if f of x is continuous on closed interval ab, and f of a and f of b are of opposite sign. That means if f of a is positive and then f of b is negative, or f of b is positive so f of a is negative. That means if these two are opposite sign, then the equation f of x is equal to 0 has at least one root between a and b. That means if the graph of the function is negative to positive, going negative to positive, then this graph must cut at least one point in the x-axis. So this is the graph. You can see easily. So this here the graph of this function f of x. So f of a is negative and f of b is positive somewhere here. So the function is continuous. That's why this must cut at least one point here. This graph cut the x-axis. So this is the roots of this function. So it may be cut several times. It depends upon the function. So now the algo for bisection method. What are the process? How we will apply bisection method of a given function? So this is the algo. So first we have, for a given continuous function, we have to find two real number a and b, such that a and b, f of a and f of b are of opposite sign. That means if f of a is positive, f of b is negative. So this, from this condition we get by applying the previous result. This is the roots lies between a and b. So the previous result going to apply frequently for the bisection method, repeated time. So so the first bisection is the a plus b by 2. This is the bisection of a and b that is denoted by x1. Now check f of x1 is 0, whether f of if x1 is 0, then x1 is the root of the equation f of x is equal to 0, and computation may be terminated. That means we get the exact root. But the problem is, when f of if f of x f of a and f of x1 is less than 0, that means f of a and f of x1 are opposite sign, then root lies between a and x1. In this case, set b is equal to x1 and go to the step 2 again. If f of a and f of x1 is greater than 0, that means root lies between other interval, not this interval. So root lies between x1 and b. And set b is equal to a1 and go to the step 2 and apply the similar process continuously until unless we get the roots. So this is the graph here. This is f of a. So here in this graph we have considered f of a is negative and f of b is positive, and similar pattern that means the roots lies in between a and b. So here first iteration is x1. X1 is what? F of x1 is positive, so roots lies between a and x1. Similarly, second iteration is x2. That means f of x2 is negative, so roots lies between x2 and x1. And then x3 is positive, so roots lies between x2 and x3, and so on. We apply this method continuously until unless we reach here. In this point, we reach to the roots. For example, we have considered one example so that the method get justified. So this is the example. So find a root correct to three decimal places and lying between point 0 and point 5 of the equation this. So this clearly in this equation, this is transcendental equation, and this equation, in this equation we cannot apply algebraic methods. So here we have f of x is 4 e to the power minus x sin x minus 1, and f of 0 is minus 1, and f of zero point 0.5 is 1.16314. So clearly f of 0 and f of zero point 0.5 are opposite of signs. So therefore roots by the again by that result roots lies between 0 and zero point 0.5. So the take bisection first section, so that means 0.25, and f of 0.25 is negative, that means root lies between 0.25 to zero point 0.5. And similarly you can take x2. X2 is another bisection is 0.37, and check whether this is positive or negative, and so on. So apply this method continuously, you will get this type of iteration. So until x9 is 0.3702, x10 is 0.3706, x11 is 0.3704, and x12 is 0.3705. So we need to find the roots up to 3 decimal correct. So here we get this thing. So the required root is 0.370 correct to the 3 decimal places. So this is all about the bisection method, and the we can bisection method guarantee to find a roots, but which root we don't know. So this is the drawback or advantage of bisection method. So thank you very much.